Hello everyone. In this video, I would like to share with you the process of outputting files for CNC machines. Use G-code system. This is the data diagram. First, I will have an order. Then, I will start order on BAZIS module. After I finish rendering the image, I will export to DXF file by BAZIS CNC module. Final, I will optimizer with Woodsoft nesting. Results include CNC file, result, a spend a material, label and DXF nesting file. That's enough data for production. CNC machine, edge banding, horizontal drilling machine. I will go into the process demo. First I have an order. Here I have wardrobe products. The bedside tab already has accessory links. Bed and headboard. A desk. A bunk. After that, I will create the project and export DXF file. Add 3D file to project. This is my project and I will save it. Select the link to the CNC module. Here, I will choose the configuration SCAD system. When you select your favorites and all, you can select the Favorites tab and choose CAD system. Select OK to finish. This is the interface after selecting the configuration. Here are the materials in the order, and which material I want to export, I will select it. Choose the appropriate configuration for the CNC machine. For example, here I will choose the Woodsoft configuration. In this, I will set up and note things. First, for the reading parameters part, I will choose panel orientation. Choose a length that matches the length of the CNC machine. Choose the flip side according to the length selected above. In the Holes section, select Create Single File. I will select the process hole with diameter more than section. Then enter the value so that the system can eliminate drilled holes without machining. For example, if the CNC machine can machine a hole with a diameter of 3, I will enter the value 2. Entering a value of 2 will remove all values less than or equal to 2. In the banding accounting section, I will choose the drill hole coordinates without including the banding. In the slot section, you can add the names of unprocessed lines to remove from the project. In the process-dependent parameters section, I will check all the operations section. To have full information on the label, check the edge holes drilling section. To have information displayed on the label. Horizontal drilling position and distance. So that I can identify drilling information when transferring parts to the edge drilling machine. In the comment section, I will set it according to the layer form and info of Woodsoft nesting. After that, I will export the file. The results obtained are folders containing DXF files. Order and Materials folder. These 4 folders correspond to 4 materials selected from BAZIS CNC. The next step in the process is to zip the folders. Normally, I will check delete files after archiving. after completing the zip file, according to the process. The next step is to optimize Woodsoft nesting. I will visit the website https://woodsoft.vn/optimizers. Then I will select the DXF nesting item. This is the interface of Woodsoft nesting. We need to pay attention to the following items. The first is the section, Post-Processor Settings. Set up to match the file structure of each machine. For example, here I have a model like this. Smart board pull and push. Command structure to turn on and off the rotor assembly. And drilling assembly. Tool settings section. I have to enter the data of the CNC machine. Into the tool list section, you can declare up to 3 tool list configurations. Next, I will declare the cutting, grooving and pocketing processing processes. Here we have the outer contours and the inner contours. Declare information such as tool number, rotation speed, cutting speed, slow cutting speed, etc. In the drilling process settings section, you need to set range and execution values for the system to recognize and assign operations. Next is Woodsoft nesting. I have notes about tool configuration, label configuration, nesting configuration, set the size of the label, parameters related to label alignment, label font. I will have a QR code set up. When you set up data for the QR code, the stamp will appear. QR code information so you can use it to find drill files. Check the list or use it to view 3D objects on BAZIS web viewer. Choose a suitable label template. Nesting configuration section. Set company name. Enter the size of the wooden panel. Enter the setback from the edge of the board. Next, I will name the order, for example, Mistra. Choose coordinate system. The appropriate coordinates are x plus y plus x minus y minus, etc. I will choose depending on each machine. In the cutting order of details section, optimized by software or from top to bottom, from right to left. In the export DXF of nesting sheets section, the system will export DXF files and CNC files in one folder. Correct the nesting diagram if not optimized, and re-export the G-code, or I can optimize with CNC machines that do not use G-code from the exported DXF file. Next to there are optimal options. Select Not care about wood grain, then all data uploaded to the system will be understood as regardless of grain direction. Select Fixed nesting result. When you check here, the system will fix the returned results with other optimizations. Same file and I can quickly optimize for many CNC machines. With different post-processors or tools, do not change the returned results. Suitable for companies with many different CNC machines. Next is priority grouping of two-sided processing details. When selecting, the system will automatically prioritize two-sided details. in the same cutting diagram, reduces flipping when cutting, but maybe the cutting diagram will not be optimal by not selecting. In the auto labeling section, we will have options for the machines. Firstly, I can export the automatic labeling file to Blue Elephant's machine. Second, I can export the automatic labeling file to Nangsing's machine. Once setup is complete, I will proceed as follows. Select the previously zipped file. Select Run Nesting for optimization. After optimization is complete, the system will return the results. And I will save the location I want. It's usually a good idea to save it in the uploaded location. For easy checking, quickly see the results. By clicking on the View Nesting Results section, upload the returned result file to the system. Select Get Nesting Result. The first is statistics and error warnings. For example, here I have parts with 3mm grooves but have not yet set up the tool configuration. It will give error warning here. And here are the diagrams after I finished optimizing. Place the parts inside each other if there is enough space. Materials with different names will have different colors. Displayed. Let's see what's in the results section. The results section includes the following content. The first one is the optimal time information. Inside this folder, the folders contain CNC machine files and labels. File statistics. Statistics and error reports. General information of orders in file result_order. Material statistics in Excel file. Information about materials, dimensions, number of panels, and total edge banding. Statistics of materials in products. This data will assist in the quotation work. Result. It has this reporting information. Error warnings. For example, there are parts that have operation errors. Couldn't find the tools to do it. Board and edge banding statistics information here. Statistics on the coverage of each plate and the entire order. Below is a detailed list of panels. This list of plate details will support the counting work when exporting the project. And at the bottom are the board cutting diagrams. Has the name of the cutting diagram, the name of the cutting part, and the location of the part in the order. Location of each detail in the board cutting diagram. I can print it out on A4 paper to see an overview of the diagram, or look at the detailed location to label the label more clearly. When looking at the diagram on the label, inside these folders are CNC programs, labels, and DXF files. For example, Material Folder 101SH. There are 8 CNC cutting diagrams, PDF label files, and DXF files. DXF corresponds to CNC cutting diagrams, so I can edit the diagram and produce a more optimal CNC file than the old cutting diagram. Or you can add more details to the cutting diagram. Or you can rely on the output DXF data to produce CNC files for machines without using G-code. For example, Homeg CNC, BCNC. Switch to the G-code file and I will open this file. I am watching a program simulation using Simco software. Automatically add smart push and pull commands to the program. Side to files automatically insert the plank pull-in command at the beginning of the program, and at the end there will be no pushing the plank. File side 1 will not have the order to pull the board. At the end of the program, there will be an order to push the board out. On side 2, this board cutting line will automatically be added to the standard board size. Perform face drilling, grooving and pocketing commands. Switch to the first side file. It will execute the entire program. This is the simulation part. For small details and details with special non-square contours, the system will automatically run to cutting lines. Optimize the path into 2 times to reduce part deviation when cutting. Run the simulation and these are drilling and grooving operations. Pocket. Cut the inner contours, and then cut the outer contours of the detail, from small to large details, from outside to inside according to the algorithm to reduce detail distortion. This is the label file. The label file has all the information. From order name, product information, name of detail to attributes in the detail. QR code. Information on edge banding on panel details. For example, this curved panel detail. You can see whether there is edge banding or not. After I have all the production information, I will go to the stages. We will proceed with CNC running and labeling, based on the detailed positions on the stamp to affix the label. Move to the edge banding step, based on the edge banding information on the label, to determine which edge has edge banding. For example, this detail has 3 glued edges. Go to the edge drilling stage. We will also identify them by the symbols on the label. The first, the side drill hole information, is above the detailed image on the label. The second is based on the HD identification mark on the label. So I have introduced to you the process of creating CNC files for CNC nesting machines. Thank you for watching.